Hello guys, welcome back to my channel Code Monger. So today we are going to solve another daily problem numbered 1514, path with maximum probability. So let's go through the problem statement to understand what's the requirement. So you are given an undirected weighted graph. It is an undirected weighted graph of n nodes, and nodes are numbered from 0, represented by an edge list where edge of I is equals to a comma b. Right, so each there is an each edge present, right, and it will connect the point A and B with probability of success traversing at edge, success probability of I. And the weight, basically in graph we have edge of the weight of the edge, right, and that would represent here the success probability. Like if you want to go from vertex 0 to vertex 1, the probability of that is 0.5. That's what given in the problem. Given two nodes start and end, find the path with maximum probability of success to go from start to end. So let's say we will be given a start point and an end point. So we have to return the maximum probability value of reaching that end vertex, right? If there is no path from start to end, return 0. Okay, so if this is the case, like in this case we have been given 0 to 2, there is no path, so the probability to reach 2, right, would be 0. Let's look at the examples now. So in this problem, the first example, they have given start as 0, end as 2, right? So the maximum probability to reach is 1 is direct path this, right, and the probability is 0.2. But there is another path, this one, so it is 0.5 multiplied by 0.5, so it will be 0.25. Why it is multiplied? Because they are dependent on each other, right? So 0 to 1 is 0.5, and then again from 1 to 2 it is dependent on this one, right? So we have to multiply it, so it's 0.25. Again, like here again we have to go from 0 to 2, but from 0 to 2 you can see there is direct edge of probability 0.3, and then there is this indirect path going from 1. So the probability of this one would be 0.5 multiplied by zero point 0.5, that will be 0.25, right, and it is 0.3. So this one is greater, so the answer would be 0.3, right? So that's all about the problem statement. Let's try to see how we are going to solve the problem, right? So if you look at the problem, right, first point is we have given start point and end point, and we have to find, right, the maximum probability. So if you are able to relate it, it's a problem of single source shortest path, right? So what I mean by that is, like, single source shortest path happens is, like, we have been given a source, and from that we have to reach a destination. So here start and end is given, right? But in single source shortest path we have to find the shortest path, right? But here in this case we just have to maximize the probability. So just that thing is opposite. Instead of shortest, right, shortest path, we have to find the path with the maximum probability. So that's only the condition that's being reversed, but rest everything is still the same. We have a starting point, we have an ending point, and from that we have to find out the from all the paths, right, we have to find the path with the maximum probability of reaching the destination. So what are all the single source shortest path algorithm? The best one that we know of is Dijkstras, right? Dijkstras is a single source shortest path algorithm, right? And that would be used to find the shortest path. But here in this case we will just tweak it a little bit so that it would give the path with the maximum probability. So what we used to do in this algorithm, right, let me show you, right? So here let's say we have the starting point as 1. Okay, so from 1 to 3, right, what's the shortest path? If you look at it, it would be 1, correct? From 1 to 4, 1 to 4, what's the shortest path? We have one direct path 10, but if you look at it, what's the other possible path? It is this one, right? From 1, 3, 4, and the total distance is 3, right? Similarly, 1 to 2, this is the what's the shortest path? There is one direct path of length 7, and then there is another one, right? And then there is another one from 1 to 2 and 1 to 3 and 4 to 2, right? This path. So the length in that case it would be 5. And similarly, so from 1 all there are 3 vertex, all the 3 the shortest distance have been found out, right? So this is what the Dijkstras will give us to do. So from here, if you want to find out the shortest distance from 1 to 3, it would be 1. From 1 to 4, it would be 3, right? And from 1 to 2, it would be 5, right? So that's what used to happen in the Dijkstras algorithm. Now, let's try to see how we are going to solve our problem with the same approach. Okay, so this is our problem, right? We have been given this graph. Okay, so in this graph, let me move it a little bit so it is visible. Okay, so this is the graph that's been given to us. Okay, first of all, like what we have been given in the problem is like all the edges and the success probability. So the edge between 0 to 1, it has a success probability of 0.5. 1 to 2 would have 0.5 and 0 to 2 would have 0.2. So that's all is denoted here, right? Now the first step in this problem is to create a graph, right? Speaking code point of view, how our graph would look like, right? So to create a graph, right, I'll be using adjacency list. So it would be list of list. So I have all the vertex like 0, 1 and 2. Okay, so from 0 vertex, how many edges are coming out? From 0, if you see, right, there is a edge 1, right, and its probability is 0.5. And then from 0 to 2, there is another edge and its probability is 0.2. Then from 1, right, it is undirected edges all up there. So from 1 to 0, there is also an edge. So from 1 to 0, and its probability, success probability is 0.5. Similarly, we have from 1 to 2, right, and its success probability is 1 to 2 is 0.5. Again, from vertex 2, from 2 to 0, we have an edge, okay, and its success probability is 0.2. And then from 2 to 1, we again have an edge and its success probability is 0.5. Right, so this is the graph that we have created. Okay, so this is how we are going to denote it in the code also. So that's how our graph actually looks like. Now before we solve the problem, okay, so as we know, in Dijkstras we are also going to require a heap, right? In this case, normally in Dijkstras algorithm, right, the priority queue or the heap that we create, right, that is created on the basis of it would be min heap because we have to find the shortest path, but here we have to find the max probability, right? So it would be a max heap. So based on probability, whatsoever is the maximum probability, it will take that out and give it to us. Okay, now so there would be some starting point where from where our priority queue would start. So that would be the starting vertex that in the problem they have given, right? So in the problem they have given us a starting vertex. In the, let's take an example of the first one. So in this case it would be the 0th vertex, that would be a start node, right? So so what we are going to add in the priority queue, right? So what we are going to add in the priority queue is the vertex, right, and the probability. So these two things we are going to add in the priority queue. So the vertex is initial because from some point has to be there in the priority queue, right? From where we are actually going to start our processing. So the starting point would be the vertex given in the question. So that would be the 0th node here, and the probability to reach is always going to be 1 because we are already going to start from that point, right? So this is the initial probability. Correct. Now other than that, we are also going to have one uh, like in the short test when we do the Dijkstras, right? There we also have a distance array, right? So the distance here is going to be represented by a probability, right? In because what we're doing Dijkstras, right? We find out the shortest distance. So for each of the vertex, what's the shortest distance to reach, that's being updated here, right? Now, but here we are going to use it for probability. We are going to use the same for probability. Now we know that for the 0th node, the probability to reach is 1, but for all others, it is going to be 0. So one by one, now we are going to pop the elements from the priority queue. And once we have that vertex, like in this case, we have the 0th vertex. So from 0, we are going to find all the vertex which are connected to it, right? And calculate their probability. And if the new probability, right, it comes to be greater than the already existing one, then we will update it. Okay, like we do in Dijkstra. Okay, so let's pop this first vertex, first edge from the priority queue, that is 0 to 1 with probability 1. So to reach 1 right now, what we have the probability is 1. Okay, so let's check from 0 to 1 there is an edge. Probability to reach 1 would be 0.5, right? So the probability to reach from 0 to 1 would be 1 multiplied by 0.5. So 0.5 is greater than 0. So this would be updated, right? So this would be updated to 0.5, right? Because this is greater than 0. Okay, so now the probability to reach 1 is 0.5, correct? And again we will add it in the priority queue. So the probability to reach 1 is 0.5. Okay, and the probability to reach from 0 to 2, so is 1 multiplied by 0.2, right? So it would be, it is now greater than 0, so it would become 0.2, right? And we will update the same in our distance array, right? Okay, and let's add that also into the priority queues. The distance to reach from 0 to 2 is 0.2. Fine. Now let's so this is the first iteration of processing. Now the first vertex edge that was there in the priority queue, this is processed. Now let's pop the another or the next element from the priority queue, and in this case the one with the maximum probability is 0.5. So this is the one which will be under consideration. So from 1, right? So this is the vertex, or this is the vertex that under processing. So one vertex is now under processing. So from 1 we have two edges, 1 to 0 and 1 to 2. So 1 to 0 and 1 to 2. Now the probability from 1 to 0, that is 0.5 multiplied by 0.5, right? So if you multiply 0.5 multiply by 0.5, so it will come to be 0.25. Okay, so 0.25 is definitely smaller than 1, so the probability to reach 0, right, would remain unchanged. Then so this one we will, the first one, right, and this won't have any effect. Next what we have is the probability to reach from 1 to 2. To do that, like to reach 1 we have 0.5 multiply by 0.5, that let's do that, it would be 0.25, right? So if you have, it would be 0.25, correct? So 0.25 is greater than 0.2, So in this case, we will update it. Okay. So what would happen is like we will remove this, it will become 0.25. Okay. So now the max probability to reach 0 0.2 is 0.25. We will add that also into the priority queue. So to reach 2, now the maximum probability is 0.25. Okay. So now that is also done. The processing of this edge is completed. So let's remove it. Now, what's the next max probability that is there, right? So it is the 1.25. So let's process the second vertex. So now the second vertex is under processing, right? So from second vertex, we have an edge from second to 0 to the current probability is point of vertex is to reach 0.25, vertex 2 is 0.25, 0.25 multiplied by zero point 0.2, right, from this path to reach the 0th node, it would be 0.25 multiplied by 0.2, that is 0.05, which is definitely smaller than the probability to reach 0, right, which is already 1. So we are going to discard that, right. Then to reach point 1 from 2, right, let's calculate the probability for that also. So once we reached 2, right, it's 0.25 multiplied by zero point 0.5. So 0.25 multiplied by 0.5, it will be 0.125. Okay, so 0.125 is definitely smaller than 0.5, so it would also be skipped, so there won't be any impact, right? So the processing of this node is also completed. Then again we will pull another this last remaining edge from the priority queue, right? So once we pull that, again the vertex 2 is under processing. Okay, so if you look at it, right, so we have the vertex to be 0.25. The current probability that we have here is 0.25, and from here, that is the vertex 2, right, its current probability is 0.25. So it would be the same processing like we did just now. So right, so 0.25, again we will have two vertex, this one and this one, right? So there won't be any impact, right, because we did the same processing again. So the final result would remain as it is and there won't be any changes. So if you look at it, right, so how the final distance array would look like, it's like this. We have three vertex, 0, 1, 2, right, and to reach 0th node, that is the starting, it would be always a 1, then 0.5 to reach 1 and 0.25 to reach the second one, right? So this is our final output, and if you check the answer, right, so the probability to reach from start to end, that would be 0.25. So that was all about the explanation. Let's try to write the code for the same. Okay, uh, so whatsoever we have discussed till now, we are going to write the same here in the code also. So the first thing that we discussed, right, was to create a graph. So let's create a list of list, adjacency list, right, of type double. We will be using double array because that's how the probability is given to us. Then we have to, for the number of nodes, right, that we have to add that many list into our graph to represent each of the vertex. So and this is how our graph is created, right? This is the basic structure of our graph. Now let's try to add edges, right? And weight also. So here what I have done is, okay, so here basically what we are trying to do is, like, for as I have explained here, right? So this is what our graph would look like. So uh, now we have already added in each of our graph we have added our array list. So for them I'm getting that particular edge, right? So they have given like from 0 to 1 there would be edge, so I'm getting 0th index of the edge, and then adding a edge and a probability. So from edge to edge, like there is edge width from to 2, and what's the success probability, right? So that's the thing. But other than that, like since we have what you say, undirected graph, correct? So undirected graph, it is there. So whatsoever the edge that we are adding, right? So it is going to be also in the reverse order. What I mean by that is, if the edge from 0 to 1, then there will be edge from 1 to 0 also, correct? So in that case, if there so we have to add from 1 also, right? Earlier we have added from edge from 0 to 1, now it is from 1 to 0, and added success probability, and success probability would be same for both of them. Now so this edges of I, right, it is given in the integer format, but the value that we are adding is in double, so we have to cast it to double here, right? And the same goes for this one. Okay, now our uh, what you say, the graph is completed. So whatsoever we have discussed in the right side, right? So our graph is completed now. Now we have to create distance array, right? So where we will store the probability. So it would be new double of n number of vertex, and fill all of them with the probability of 0, right? And it is double, so we will put 0f. Then we will create a priority queue, and we are going to make it of type double, because we are going to store the two things there, right? Here, as I have shown, the vertex and the probability. Okay, so let's create a priority queue, and let's pass the comparator also here in itself while creating it, right? So double dot compare b of 1 comma a of 1. So so we are going to have a max heap, right? Max priority queue. So whatsoever is the maximum value would be returned by here. So why we are passing b of 1? Because because basically we wanted to sort values on the basis of probability, right? So and the probability would be present at the 1th index. Okay, so that's why we have added. Now we have to do some initialization from where our processing would start. So our processing would start from the start node that's been given, right? So we have to add that in our priority queue. Okay, so whatsoever is the start node, we will add that and add its probability as maximum, because 1L, because it will always be reached. Then we are going to make the distance of start node is equals to 1L. Okay, fine. Now let's start processing by pulling one by one item from the priority queue and finding its nearest edges and doing all the computation. So while pq dot is empty is equals to false, right, we have to pop element from the priority queue, and that would represent at pq dot poll. Now once we have the location from where we want to start, then we will find out all the possible edges from that node, right, to the neighbor node, right. So right now we were at and want to find out all the two or the destinations. So to do that, let's use graph to get all the edges, right, and it would be at of 0. Okay, but this at would be in double format, so let's cast it to int. Okay, so once we have done that, now let's try to calculate the new probability. So now to do that, what we have to do, what's the probability of the current node that we have, and from there what's the probability to reach the new node. Okay, so if we multiply that, right, and we will get the new probability. Okay, and if this new probability that is coming, right, if it is greater than the existing one, then only we will update it. Okay, so let's try to do that. If the new probability is greater than the one that is already there that we have stored, right, then in that case we have to update it, and it would be in int, right, this part, because it is an index, so we have to cast it to int, so that's why we have done that. Okay, now so if this is the case, then we have to update this distance, right. So this distance that we have already calculated, we have to update it with the new probability. Since new probability is the greatest one, so that would become the new probability, and we have to add this in the priority queue. Fine. So yeah, it would be 2, that where we are going, and add its new probability, right. And once this is all done, it will calculate and put all the maximum probability in this distance array, right. So once that is done, we have to go to the end node to just return the maximum probability, right. So let's yeah, that's all about this problem, right. So let's try to run and see like all the basic test cases are passing or not. Yeah, so if you look at it, all the basic test cases are passing. Now let's try to submit it. Let's check out the code, something might have missed. Okay, so if you look at it here, right, the edge should be from I instead of 0. Okay, so that was the problem. Let's try to submit it once again, and if we submit the code, right, yeah, now it is working fine. So yeah guys, that was all about the problem. So let's try to understand. If you have any question, ask that into the comments section. I'll glad to answer that, and do subscribe to my channel for more daily content like this. See you in the next video.